Number 14, we have a function and an interval, and we need to find approximations using Riemann sums. So part A asks us to find an approximation of the area under the curve using 6 subintervals and left endpoint. So the first thing we need to consider is if we have 6 subintervals, what are our endpoints going to be and how wide are our intervals going to be? Where our interval is -1 to 2, so that's an interval width of 3. If we're splitting 3 into 6 intervals, that would mean that each interval has a width of a half. So our width is 1/2. And the only other really important thing we need to think about is that we're using left endpoint. So if it helps to draw like a map of the interval, you might want to do that. So we're splitting this into 6. So we have this type of thing going on here. And for each interval, we're using the left endpoint. So since each of these intervals are a half, I think the easiest way to think of it is if we're using left endpoint, we're starting with -1. We have to use that. And then for each next one that you use, instead of trying to just figure it out, just add a half every time, because that's the next point, because all these are half wide. So therefore, our sum, our estimate, would be 1/2 the width times the height of each rectangle. So remember, the height of each rectangle is determined by the function, and you plug in each of these points. So this function, looks like something, and every rectangle is going to have a height of whatever the function is at the left endpoint. So the first rectangle, for example, would have some shape where we determined its height because f of -1 was right here. So then the next rectangle is because f of -1/2, because that's the next number, was that height. So we're just going to plug in f of -1, f of -1/2. We're going to keep doing this because we know we have to have 6 of these because we have 6 subintervals. And each one we just keep adding a half. F of 0, f of 1/2, f of 1, f of 3/2, and that's 6 things. So this expression right here would give us the estimate. So I'll leave that solution to you because that'll take a while, just plugging into the calculator. All you're doing is plugging in all of these numbers into f of x. You add them all up, and you multiply by 1/2. So again, we're doing this because this is the area of all of the rectangles. It's width times height, width times height, width times height, etc. We knew the widths were all 1/2, and the heights, when you use left endpoint, are determined by the left ends of each width. So part B, it again asks us to do 6 intervals, so we know the width is again 1/2. The only difference here is that we're asked to do midpoint instead of left. So we still have the 6 intervals that we had before, and our expression is going to look almost the same. We still have 1/2 times, and we're going to have 6 things here that are all f of something. But in this case, we're not using the left end of each interval. We're using the center of each interval. So this one we have to consider what would the center be of each one. So the midpoint between -1 and -1/2, this first interval, would be -3/4. So we're going to have f of -3/4. The midpoint of the next interval. The next interval goes from -1/2. Let me put the whole numbers on here, so maybe that'll be easier. The next interval goes from -1/2 to 0. So the midpoint of that would be -1/4. You can probably see that there's still going to be the same pattern emerging that there was before. All of these midpoints are a half away from each other, so you don't need to figure it out each time. We're just adding a half, just like we did up here. We just started on a different thing. So after this, we're just going to keep adding half to each one. So f of -1/4, the next one's f of 1/4. Then we get f of 3/4, f of 5/4, and f of 7/4. So again, I just got those quickly by just adding a half to every number. Now we have 6 things, 6 heights, which means we have 6 rectangles, width times height, width times height, width times height, etc. Again, plugging all of these numbers into your function would give you these values. You add them all up, multiply by 1/2. That's our estimate for the midpoint using 6 subintervals.
The Teaching Center, UF's Learning Resource Center.